Hello, my name is Donovan Gregory, and welcome to my SPED talk on neural networks. I'll be walking you through today, teaching you exactly what a neural network is and how it can be useful when used in combination with conventional computing. So, to start us off, we need to ask ourselves what are the most fundamental questions when trying to understand anything? What is a neural network? So, a neural network is more commonly known as an artificial neural network, or an ANN, which an ANN is an information processing paradigm that is based on the way our brain processes information. The key element in this paradigm is exactly how our brain manages to do that. And it does that through a large number of highly interconnected neurons working in unison to solve a specific problem. Um, Artificial neural networks learn by example, much like a person. They are used currently for specific applications like pattern recognition or data classification. Um, Learning in biological systems involves adjustments to the synaptic connections that exist between neurons. And just like in biological systems, we have to do that with artificial networks, neural networks as well. Alright, now that we kind of understand what a neural network is, we kind of have to ask ourselves, what is the purpose? How is this actually applicable and useful? So there's four main key components as to why a neural network can be useful. The first one is that it has adaptive learning. It has the ability to learn how to do a task based on the data it is given for training. And so it learns as it grows. The second is self-organization. An artificial neural network can create its own organization or representation of the information it is receiving, the information that we give to it. The third is real-time operation. All the computations that are happening can be carried out in parallel, which, if you have the correct pieces of hardware, you could take advantage of that capability to speed things up and do things in real time. The fourth and final one is fault tolerance, because of redundant information coding. Partial destruction of a network leads to corresponding degradation of performance. However, some network capabilities may be retained even with major network damage. Basically, if something is taken out of its instruction, it'll still be able to perform to a degree. It won't just immediately crash and burn. And even if you take out major components of its programming, it'll still at least try to do what it's supposed to, though you will get less accurate results. Now, the final question that we should cover in the little time that we have, neural networks is really a topic that you could dive really deep into, but for this brief overview, we're just going to answer one more question, and that is how they compare, a neural network compares to conventional computers. And so the real difference between the two is that conventional computers uses an algorithmic approach. You know, x plus y equals z. It can do arithmetic really well. It follows the programming, but unless the specific steps the computer needs to know are there, the computer can't do anything. It will just stop, crash and burn, whatever you want to say. Now, that restricts the problem-solving capability of conventional computers. It's different than how, for instance, we compute. We can work through a problem in ways that computers can't. Now, a neural network is designed to process information similar to the way that we process information. The neural network itself is composed of a large number of interconnected neurons working in parallel to solve the specific problem, as we talked about earlier. Now, they learn by example, so they cannot be programmed to perform a specific task. The examples must be selected to teach them the task that they need to do. And they have to be very carefully selected, otherwise you'll be wasting time, or you may be causing your neural network to function incorrectly. So that can cause a slight disadvantage in that the operation can become slightly unpredictable. With conventional computers, it's much more straightforward. As long as the instructions are there, then it will work predictably. If there's anything that goes wrong, it is not the computer's fault, but rather a software or hardware problem. So, you may think that these two are different, and a lot of people might start to think that they are in competition, but really they work well together. Because in traditional computing, with the algorithmic approach, it is really good with doing things like arithmetic, like I said earlier. Whereas with more complex tasks, you might want to teach a neural network to do it in order to perform at maximum efficiency. A quote that I found that I thought was really helpful in understanding this, just neural networks in general, is that neural networks do not perform miracles. But if used sensibly, they can produce some amazing results. And I think that, in a nutshell, summarizes what a neural network